Hi, my name is Marnia.
And I'm Corey.
And we build robots. We're building the TE+ND Rover, the Terrestrial Exploration Nurture Designed Rover, which is basically a walking rover. It has legs based on the Theo Jansen style walker, Strand Beast, with a hydroponic growing garden on top. So the hydroponic growing station on top is built from what I call a translucent porcelain sponge. It's basically a ceramic sponge with little holes for the plants to be planted, and the cell diameter of this sponge is such where the root system can have the perfect amount of moisture as well as the perfect amount of oxygen air, which it needs to grow. We're putting some native California plants that are pretty traditional, some sticky monkey. You'll also find some golden poppy. You'll find some purple lupin. I'm also going to put some things that are not native, things that have come in and have taken over and we now find in the landscape, things like forget-me-nots, and I'm going to actually put those in so that we can talk about what plants are native and what plants are not native, and how they change our ecosystem.
The mechanics of the rover are inspired by many different things. First of all, there's the Theo Jansen walking mechanism, though our system is a broad interpretation of that because we can optimize it in various different ways to meet our own ends and to simplify it. The walking system is purely mechanical. There is no complicated actuation of the legs. It is a simple mechanical drivetrain, which makes it very robust and very simple and actually very elegant and beautiful. What these interesting properties allow for is for a single gear, primarily this one, to move at a constant rate. And by doing that, it allows this gear over here to move at two different rates, quickly and then slowly. And the reason we do that is because we are trying to allow our machine to have an optimal gait, and instead of programming two different speeds and having the motor just travel at two different speeds, we're handling it mechanically because there are other advantages. To give you another sense of scale, here's the gear drivetrain for the smaller of the examples. This is just a gear set. And as you can see, there's the motor. And here's the size of the motor we'll actually be using. The brains of the rover are going to be based on embedded Linux and/or Android platforms running on embedded ARM systems like the Beagle board. That would be for high-level brain functions such as sensor input and video recognition. For lower-level stuff such as guidance, we will be using an Arduino platform called the Ardu Pilot, or another derivative or variant of that, which has IMUs for detecting motion, GPS for detecting position, and a magnetometer for detecting orientation.
So if you're interested in becoming a participant, if you're interested in helping us with the project, if you have a school in mind as a deployment site, please feel free to give me a ring at my email address, tendrover@gmail.com, or check out our website, www.tendrover.com. Thank you so much for watching our Kickstarter video, and I hope this inspires you to donate today.